Hello and Assalamualaikum. We are from Group 4, Section 3 from Engineering Management, and today we would like to present about our group assignment, which is PV system, study case number 1, which is, as we know, there are several PV systems that are installed on rooftop at several faculties such as FTV, FKE, and others. So we need to investigate about them. So our lecturer is Dr. Razi bin Ambar. So without wasting time, I would like to introduce our group members. So first one is Muhammad Afiq Aiman bin Zulkifli, CE 200-14A, Muhammad Faiz bin Hamidun, DE 2024, Muhammad Amir Ashraf bin Uthman, AE 20001, Ahmad Nazrin Hakim bin Aziz, CE 210195, and the last one is me myself, Muhammad Syamil bin Abdul Hadi Hakimi, DE 2035. So for the introduction, PV system, the most compromising renewable energy source in Malaysia, is for photovoltaic PV technology because of the country high sun radiation. To promote the usage of PV system, the Malaysian government has started a number of programs including renewable energy. The majority of PV systems are single phase and are installed at the request of the customer. In this case study, we will conduct to investigate the total number of selected buildings that could possibly install the solar PV panel toward the diffusion of the sun irradiation at UTHM. And the objectives are to stimulate activity that will lead to cost reduction, to increase the awareness of PV system potential, and the last one is to advance economic development. That's all from me. Thank you.
Assalamualaikum, and my name is Ahmad Nazrin Hakim bin Aziz. Number metric is CE 210195. I'm going to explain about the background of and previous research work and primary data collection and appropriate method. For the background is because resources and energy are necessary for industry, agriculture, and commerce. They play a significant role in the success of the nation. Every day, there is a greater need for energy. The main energy sources are gas energy sources, oils, and other substances. However, these resources are governed by the laws due to their risky nature and potential for causing environmental harm. Clean energy sources are necessary due to atmospheric pollution and global warming. And For the previous research work, in order to develop hybrid energy systems, a thorough investigation was necessary to gather factual data regarding the UTHM renewable energy resources capacities, the benefits of using renewable energy choices to access energy resource capacities, and standalone hybrid systems have been highlighted in a number of research studies. The subsequent work of several authors was presented for a range of hybrid systems from different era, location, and nations. The research was conducted on a few rooftop structures on University Tun Hussein of Malaysia in main campus, UTHM. For the primary data collection and appropriate method, this table is a summary of impacts by Malaysian renewable energy technologies. And the type of energy technologies, firstly, is biomass. The negative output is fuel sources, uncertain, and requires land for waste production. Facility requires sizable amount of land and water. Effects surrounding biodiversity. Emission of greenhouse gases such as deadly methane and CO2. Next is wind. Native population displacement, soil erosion, reduced agricultural land, ecosystem disturbance. Next is hydro, alter migrating birds, flight path, electromagnetic interference for radio signals, consequential noise from rotating blades, and lastly eyesore to the landscape. Okay, next is solar power plant, requires sizable amount of land, poses environmental hazards if the production process is not handled appropriately. Lastly is solar BIPV. The negative impact is poses environmental hazard if the production process is not handled appropriately. Okay, now for the table 2, summary of Malaysian renewable energy technologies in comparison. The type is firstly biomass. The source is limited. Cost per kilowatt hour high. Capex is high. CPEX low. Land requirements is high. Feed category is inclusive. And for the wind, the source is limited. Cost per kilowatt is high. The capex is low. The CPEX is average. Land requirements is low. Feed category is not listed. Hydro, the source is limited. Cost per kilowatt is low. The capex is extremely high. The CPES is high. The land requirement is extremely high. And the feed category is inclusive. For the solar power plant and solar BIPV, the sources are both abundant. The cost per kilowatt both are high. The capex is both also high. The CPS is also high. AS low. The land requirements, the solar power plant is high, and solar BIPV is low. And for the feed category of both solar is inclusive. Okay, for the table 3, electricity consumption and cost price provided by TNB. So this is the building FPTV, FKAS, FSKTM, and FPTP. And the average electric consumption, average cost price, total price paid to TNB, and total roof area. So this is the price of each buildings. And the table 4, the same building. The table 4 it shows solar PV panel energy consumption by provided area. The PV area panel, the total PV panel by total area unit, electric consumption, and total PV generated. As you can see, the PV area panel M2, they are all the same numbers, and the electric consumption PV panel unit also have the same numbers, which is 100. Okay, that's all from me.
Assalamualaikum, my name is Muhammad Faiz bin Hamidun. My metric number is DA20024, and now I will explain about our project time frame. Okay, this is our Gantt chart for our project. Here, this is the list of the tasks that we do. This is the date, 21 until 20 January, and this is the progress of our project during completing this task. We start with 21 November until 26 January. I think that's all from me. Thank you.
Hello, my name is Muhammad Afi Ahmad, and today I will present to you about the project costing. So, first, this table shows how much money that solar panel can save in electric bills. As you can see here, for this project, we use a 10 kilowatt solar panel grid. So, this is the component pricing. We use 275 watt rated solar panels. We use 36 of them. Then we use two 5,000 watt power inverters. Then we use two multifunction utility meters, the required electrical panels and its components, plus the rails, screws, bolts, nuts, and the required fittings. So we have the total price for components on about 30,670 ringgit and 80 cents. For the installation, we use short-term contract laborers. So we hire 5 workers with a wage of 100 ringgit per day, and the duration is 7 days. So we have a total of 3,500 ringgit. So the total expected expenditure, including miscellaneous funds, which include food, water, in case of missing tools, components, and of course emergency purposes, we have a grand total of 36,170 ringgit and 80 cents.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Imran Ashraf Osman, and my metric number AE2001. So for the conclusion, in this case study, in order to provide statistics on the consumption of electrical energy, we are starting to get data from the rooftop area of all buildings inside UTHM. So we choose 4 buildings, which is FPTV, FKAAS, FSKTM, and FPTP. After that, we also go into further detail on photovoltaic technologies and calculate the costing of installing solar panel. So the cost of installing solar panel is 36,170 ringgit. Therefore, because rooftop photovoltaic systems are secure, affordable, and efficient, we suggest everyone to utilize them. And Malaysia should look to UTHM as an example. So that's all from me. Thank you.